Hello everyone, this is Umamaheswarareddy Chintam. I'm a solution architect working with Calans. Welcome to the Conference 42, Site Reliability Engineering, occurring on April 17th. Without having much delay, let me get into today's topic. Yeah, today's topic I'm speaking about how we can enhance SRE practices using AI and how we can build more resilient cloud-native platforms. In this session, we will identify how AI capabilities are transforming site reliability engineering practices in the modern organizations. And also we'll explore some practical implementations that drive the improvements in different aspects such as reliability, efficiency, and cost management. Yeah, we can first see the convergence between AI and SRE. For this, we will first go to the traditional SRE practices, where manual instant response workflows requiring human intervention in every aspect of reporting the incidents. Also, the reactive monitoring focused on current system status, not any other future we cannot predict here. And also we have mostly is a static rule-based alerting when the threshold meets a particular point or something. And also we are not going to do any historical. It is always go with the historical analysis and do the necessary performance things. This is how if we have been dealing with the traditional practices. When it comes to unique practices, here you are doing some kind of automation, and also we will have self-healing capabilities for any problem that arises. Along with that, it also does this reactive monitoring that forecast potential issues. Then you'll have the rather than static alerts. Here you will have the intelligent alerts and also dynamic priority adjustments. Forward-looking insights through pattern recognitions. These two areas are very important when you compare with the traditional and AI. When it is traditional, you are always with the handling with the static related things and manual efforts. When it comes to AI in SRE space, you are doing the more automated, predictive, as well as intelligence. You will apply some kind of patterns, recognitions based on that. These two approaches also, you can easily identify where I'm navigating in my further slides. This way, you are going to reduce MTDD is going to be 25%, where it can identify the detection and potential issues. These are some of the key performance improvements. Also, service availability, it is going to improve by almost 30%. You will identify the detect problems early, around 23% improvement here. In case of alerts, it's going to be reduced almost 27% because of the AI involvement in the site reliability. In this triangle, we'll go from bottom to top. First, we'll take the AI-driven observability. First, we'll take the bottom one, which is a comprehensive telemetry, where strategic data collections that optimizes signal to noise ratio while ensuring complete visibility across the stack. It is the more robust area where you will capture all the information as the required processing here. Then we will apply the machine learning models where it automates the baselines. How it helps is you can have dynamic thresholds that continuously adapt to seasonal variations and growth trends and usage patterns. On top of it, you will have once you have the comprehensive telemetry and automated baseline, you can find the patterns. That is what pattern recognition plays. Advanced algorithms that detect a non-obvious relationship between seemingly unrelated systems and services. On top of patterns, we will have the intelligent visualization, how you look at from the AI point of view. It is a more reliable, real-time, context-based dashboards and automatically highlight what are the critical metrics and potential issues that may arise. Now we'll go for anomaly detection using machine learning. First, we start with the base establishment. In base establishments, we'll have the stipulated algorithms where it learns normal operation patterns and performance signatures across the distributed systems. Continuous monitoring. Real-time telemetry systems are, or streams are analyzed against established baselines with microsecond precision. Deviation detection, how it moves, okay, it is going in the parallel line, what is the planned one, which is in the threshold or not, and how it behaves based on, then it goes to the deviation detection. Okay, once you have this setup, if something is happening, false positives or behavior of these algorithms, then it will go to the model refinement. Once you have the machine learning models continuously evolve through automated feedback loops in this spiral, we can improve the accuracy over time. That's where the machine learning helps to find the anomalies in SREs. This slide talks about how powering classic engineering, intelligent test designs, AI algorithms analyze system dependencies to identify critical failure points and design targeted experiments with maximum learning potential. Second point is automated execution, precisely controls failures simultaneously deploy during the low traffic window with comprehensive safety mechanisms to prevent cascading production impacts. We need to identify, okay, what was the low business hours so that we can execute the necessary scripts so that the any problem comes, the impact will reduce. We'll have the real-time analysis, sophisticated monitoring captures system degradation pattern and compare actual resilience metrics against with the machine learning predicted failure responses. Resilience improvement, identified vulnerabilities trigger automated remediation workflows that implement infrastructure changes, enhancing the system durability against future disruptions. How the natural language processing for post-market analysis? Once we have those things, how your natural language processing NLP works for analyst purpose. In this, we'll go one after one. Automated instant documentation. AI transcribes uses organizes to communication during the instance. It identifies the pattern recognition. System identifies similar with the previous instance like that. Then work on the root cause analysis. NLP extract all casual relationship from technical discussions. Then it find out all the necessary information for the knowledge-based enhancements automatically, and it updates the books as well as documentation related to the entire post-mortem analysis. Anything happened, what happened, why any problem occurred, and how we can improve our predictive algorithms in future. This helps. This step is very important for lesson learned purpose. Let's take one case study here before jumping into the other topic. Mainly we are focusing now on the financial service platform. Here, it is all related to dollars, numbers. The challenge is if you take a critical payment processing system, if any outage happens, in a particular business, let's say it is almost 150K revenue loss per hour downtime. If you implement these sophisticated algorithms in machine learning, you can predict, identify the transaction flow and analyze before they cascade into the failures. Mean time to resolutions dramatically reduced from 45 minutes to 12 minutes, improving customer experience. That automatically helps to bring up uptime is more, then it will inherently helps the customer satisfaction. Return on investments, if you say, it creates almost like a $3.2 million savings through enhanced system availability and prevents revenue impacting outages later on. Here we go to AI enhanced capacity planning. In this session, I probably highlight the top headings. It is mainly historical analysis, demand predictions, scenario modeling, and automated provisioning. It is like a spiral loop. We have to identify what is the available data. Then we need to find out what is the demand. Then find out the model that works. Then you have to automate that steps, orchestrate those areas, how we can proactively scale the infrastructure or any problem coming up, and how we can effectively eliminate any cost for provisioning. Yeah, it is like simply, okay, how much you need, that much you assign the infrastructure concept. If it is a peak load is coming, since our models are efficient, it identify and improve the elastic means. How we can implement this strategy? First, we need to assess the current maturity. How we need to evaluate the existing SRE practices and identify the gaps. You have to start with small and experiment around it, then build internal area, develop cross-functional SRE skills with the teams. Then we go with the successful scaling of all the entire organization level. It is all okay. First try tested, then you feel comfortable, then talk to all the within the teams and implement within the your developed area. Then we can go with the entire company level changes. That's how we can scale. In this exercise, what are the key takeaways? You can measure the impact based on these practices. You can identify how to quantify the improvements and reliability of the metrics and cost efficiency. How it evaluation, not a revolution. It is all start small, starts with the targeted implementation that complement existing practices, then improve the skills. Any successful thing you need to have invest in both the technical capabilities and organization culture. That helps a smooth transition and have a better future with advancing technologies. Then, of course, you have to look at the forward looking, where SRE will increasingly rely on the artificial intelligence to manage complex or distributed systems. Now, we'll go with what is the role in enterprise application integration in modern cloud environments for SRE. In today's fast-paced and distributed systems, enterprises are leveraging cloud infrastructure to host, manage, and a wide variety of applications. Especially integration of these applications is critical to have a unified system that functions smoothly regardless of the underlying infrastructure. Why SRE and integration matters? Every time you go with the API protocols to talk to your backend systems and front-end applications, that is where the integration also plays a very critical role, where I have been expertise in my career. If you go with the cloud-based integration, the cloud provides flexibility, scalability for integrating the applications, data sources, and systems across on-premise, hybrid, or multi-cloud environments, tenants. If you go with the iPaaS, that is integration as a platform as service, there are multiple iPaaS solutions like MuleSoft, Delbumi, Azure Logic Apps, helps integrate applications and data sources in the cloud. Not only iPaaS, you have a PaaS applications such as SAP Integration Suite and other areas where you can develop your own integration models. That also helps in the integration area. When it comes to API management, these are the critical for cloud AI. In SRE space, managing and monitoring these APIs is crucial to ensure the uptime, scalability, and reliability. That's where I was talking about AI and SRE relation. There are so many APIs you need to talk back and forth using REST services, lightweight applications, lightweight protocols, all the stuff. What are the key takeaways, techniques applied in AI for site reliability engineering? You have predictive analytics, anomaly detection, root cause analysis, automated decision making. In predictive analytics, AI-driven predictive analytics can forecast system behavior, also detect potential failures before it occurs, so that SRE teams can proactively manage and address those risks. For example, predicting traffic spikes and resource bottlenecks, enabling the auto-scaling in cloud environments. Anomaly detection. AI models can analyze large volumes of data to detect anomalies or performance in integration systems, allowing for faster identification of issues in the cloud environment. Okay, for example, like AI-powered systems can detect usual patterns in API calls of database queries, triggering automated alerts to SRE teams. In root cause analysis, AI can assist in diagnosing the root cause of failures by analyzing the logs, metrics, system status across integrated applications. This accelerates troubleshooting time and also incident response. Example like AI tools can correlate performance issues across microservices and identify the exact service causing latency, aiding the faster resolution for the teams who are working in this area. Also, automated decision making. AI can automate decision making in cloud AI, such as load balancing. Yeah, you have load balancers even nowadays with F5 and all, but this helps much more better to boost those as well. Scaling operations based on the real-time analysis of application performance and infrastructure health. Using the machine learning models, predict server load and automatically adjust resources to ensure optimal performance and optimum time. In conclusion, the future of AI, cloud, AI in SRE, it is a continuous evolution. Yeah, you know that cloud services and AI technologies evolve every day. The SRE teams will have even more powerful tools in coming days and to ensure the reliability, performance of integrated applications from across the enterprise. During this process, we can improve the automation. The combination of cloud-based integration, AI, SRE principles will lead to more automated systems, reducing the manual intervention and improving the system uptime at the same time. In this fast-paced world, you have to have a good collaboration in this space. SRE teams will need to have a good collaboration with the DevOps teams, cloud architects, and data scientists. For what purpose? To build a resilient, scalable, and intelligent system. That is the goal for today's SRE topic, including the finance system example, integration examples, how we can enable the systems in the past future technologies, how we can utilize our machine learning models, how we can use our natural language processing models. That helps to have the better and the best SRE deals going forward into the enterprise applications across the company organization. Thank you.